talk about Laplace transform. Transform is something that takes in a function and gives you back a function. And in most cases, you get a function back with a function that's that has a different variable than what's given. Among these transforms, there are like other kind of transforms, such as Fourier transform, Laplace transform. There are some others that I don't even know that well, like Radon transform. It's just one of those transforms. But you just happen to see, this happens to be the first kind of transform that you've seen in your life, okay? Let me use blue. Okay, so we define Laplace transform of a function. Let's say it's a function of t as this integral from 0 to infinity of e to the negative st of the function integrated. So just to see what it means, maybe it's better to think about an example. So suppose you have function ft equals to t squared. I want to know what happens to the Laplace transform of t squared. So you calculate this right side, which is integral from 0 to infinity of e to the negative st of t squared dt. What's that doing? Well, let's see. This is a product of an exponential function with a polynomial, and it seems like you need integration by parts to do it. So let's do the integration by parts. We're going to do it in the tabular method. Plus minus d integral t squared differentiates to 2t, 2t differentiates to 2, 2 differentiates to 0, and e to the negative st integrates to negative 1 over s e to the negative st. See, anytime you integrate e to the at, 1 over a pops in front. So that's what I wrote here. Integrating again, you get 1 over s squared, e to the negative st. Integrating again, you get 1 over negative 1 over s cubed, e to the negative st, plus, minus, and then if we start multiplying like that, it's not working well. Start multiplying like that, I get negative t squared over s e to the negative st from here. If I multiply here, that's negative 2t over s squared e to the negative st. And this is the last one. This will be negative 2 over s cubed e to the negative st. And then the last line has to be multiplied and integrated, but integrating 0 just gives you a constant, and especially because this is a definite integral, that constant plays no role at all. So all we need to do is just quote these things. Okay, so let's just copy this over here and see what happens. Okay. So you have negative t squared over s squared e to the negative st minus 2t over s squared e to the negative st, and negative 2 over s cubed e to the negative st. And into this function, I have to plug in infinity and 0. Now, one thing that you have to be careful is, because this is an integral with respect to dt, these values are values for t. So you're not supposed to plug these into s, you're supposed to plug into t. Right, so we're going to plug them into t.
Should that just be s?
Yeah.
Where?
For
First one,
t
remember
squared
that?
over.
Oh, that should be s. Yes. Okay. Now, there is one thing that I should have noted here. There's an assumption that here that S is some positive number. Okay. So some people say S is greater than A for some positive number A. Now why do you have that? Well, that's because of this thing here. See, think about what's going to happen if you plug in infinity here. What is e to the negative s times infinity?
0.
Right. This is like 1 over e to the s, no, e to the s times infinity, and as long as s is positive, this times this is positive, so this times this is positive infinity, so you have e to the infinity, which is 0. Right? What if s is negative? Then you can't say that, right? If s is negative, negative times negative is positive, and you get positive times infinity. Any positive number times infinity is infinity, therefore you get infinity. E to the infinity power is infinity. So if s is positive, then it becomes something nice, it's 0. So it's going to be 0 here, 0 here, 0 here, right? Whereas if s is negative, then you start having a headache. You don't know what to do. Okay? So people didn't want to have to deal with the situation where s is negative, so they just assume that s can only be some positive number. Okay? For our purposes, this will rarely become a topic in our discussion. So it's just the minor thing that I'm imposing here. Okay? All right. So if you plug in infinity here, what do you get? This t. E to the negative infinity gives you 0. E to the negative infinity gives you 0. E to the negative infinity gives you 0. So everything is 0. Now there, I am kind of skipping something when I say that this is 0, because if you plug infinity here, what's that? That's infinity, right? If you have infinity times 0, is that 0? Not necessarily. Sometimes it's 0, sometimes it's infinity, sometimes it's some number in between, right? So I really have to compute this limit, t squared over e. So I really have to think about what t squared times this thing is. Well, it just happens that because t is growing to infinity at a polynomial rate, and this bottom here is growing to infinity at an exponential rate. Which grows faster? Exponential functions or polynomials? Exponential functions grow faster, much faster than polynomials. So if you have a polynomial divided by exponential function and they're both growing, what's the result? You'll still get 0. Okay, so there is something that I'm just hand waving here, but if you really work out this limit, you'll see that it's going to be 0, 0, 0 for the case when you plug in t equals infinity. Okay? All right, so the result of that calculation shows you that you get 0 when you plug in infinity, minus, what happens if you plug in 0? If you plug in 0, this gives you 0, that gives you 0, there's nothing here. Oh, here's t. So you get e to 0. What do you get?
2s times 1.
Times 1. E to the 0th power is 1. Right? So you end up with 2 over s cubed. And here's a result that we just figured out. We found out that if you take t squared and do that integral as given by the definition of the Laplace equation, we get 2 over s cubed. Okay. Now looking at this, let's think about some things that we can learn from this example. We see that I plugged in a function of t and I got a function of s. Okay. So this transformation, you have to supply a function of t, it gives you back a function of s. Otherwise, it kind of doesn't seem like there's any kind of pattern. It's really hard to figure out what kind of pattern there is between this t squared with 2 over s cubed. Okay? unless you do a little more calculation. So you can do the same kind of calculation and try out Laplace transform of t. And it's basically the same thing. The only thing here is you get t instead of t squared. So it'll be t, 1, and 0. It'll be simpler, right? And if you do that calculation, you find out that the integral is 1 over s squared. And then if you do Laplace transform of 1, which is even simpler. Oh, maybe this is so easy that I should just do it. So let's try Laplace transform of 1. Let's try Laplace transform of 1. That means if I want Laplace transform of 1, the function, see, this is getting replaced in here, right? So I should plug in 1 here. And when I integrate, what's the interval? It's just negative 1 over s e to the negative st, and you're plugging in infinity and 0. When you plug in infinity, as before, e to the negative infinity gives you 0. When you plug in 0, e to the 0th power is 1, so you get negative 1 over s. And therefore, you get 1 over s. So this is what you get. And then we can do this for many, many different functions. You can try sine, cosine, tangent. No, you can't do it for tangent. Sine, cosine, exponential functions, exponential function times cosine, many different things. Okay. Now, to give you some idea of what this means in general, here's what happens in general. If you have Laplace transform of t to the nth power, you get n factorial over s to the n plus 1. And as you can see, if n is 2, you recover our calculation, 2 over s to the third. Now what would this mean for, say, t to the cubed? 3 factorial over s to the fourth, right? 6 over s to the fourth, just like that. Okay. Now, one thing that might puzzle you is when n is 0. What is t to the 0th power?
1.
1, right? So according to this formula, it says 0 factorial over s to the first power. Does that agree with this? It does, because what is 0 factorial?
1.
It's just 1, okay? Yeah. So I'm going to do more examples on this to show you different transformations. But a final remark is that for this to be defined, you need a function that's defined from 0 to infinity, right? And therefore, you can't do a Laplace transform of, say, a tangent function, because tangents have vertical asymptotes where values are not defined. Another thing is, sometimes you might have an integral, because you have an infinite domain, this integral may not be finite. In that case, you can't define it either. So, for example, if you have a function that's growing very fast, for example, e to the t squared, that grows really, really fast, right? Laplace transform of such functions does not exist. Okay? However, if you had like a function of e to the 2t, you can define Laplace transforms. Okay? So we'll talk about those examples more.